Okay, suara jelas? Screen okay? Nampak semua? Good. So, today we will start on your topic 2 as I have discussed with your tutorial lecturer. So everybody agree on we are starting on topic 2. A lot of theory, a lot of concept. So if there is anything that you don't understand, make sure you ask. Okay? So the entire topic today about topic 2 will be talking about your Bohr atomic model. What is actually Bohr atomic model? If you remember in your SPM last time, okay, one of the things that I remember so much from my SPM is you will be drawing this thing. Betul tak? Kat sekolah. Yang cikgu kamu ajar lukis, yang cikgu kamu ajar lukis, 2, 8, 8, so on and those. Okay, yang di mana energy level pertama kamu boleh lukis 2 elektron, lepas tu 8, lepas tu 8 and so on. Okay, so this is actually Bohr atomic model. This thing is actually your Bohr atomic model. Okay, in this entire chapter, generally, we will be talking about all this model and this electron. Okay, so for this 2.1, we will be talking about this model first. Who proposed this model? Who made up this atomic model? This atomic model is made by Niels Bohr. It's proposed by Niels Bohr. Okay. It's actually proposed by Niels Bohr, and Niels Bohr actually proposed a 4 postulate for this Bohr atomic model. Okay, we'll talk about the 4 postulate later on. This atomic model just generally let you know you have your nucleus. We have talked about that. Everybody know where is your nucleus. What's wrong with the pen? All right. So we have the nucleus, and then in your nucleus, we know that you have the presence of your proton. So proton and also neutron. And we know that your proton over here will carry the positive charge. Okay. Okay. So we know that your proton carry the positive charge. And then all these other things, color lain-lain ni, yang biji kecil ni, yang biji kecil-kecil ni semua adalah elektron. Dan cikgu kamu ajar dulu, in the first shell, in the petala pertama adalah 2 elektron sahaja. In the next week video, in the next week lecture, we will mention or we will discuss why is a 2-8. Kenapa 2-8? Kenapa bukan 8-8-8? Kenapa petala pertama hanya 2 tapi petala kedua adalah 8? Cikgu dulu suruh hafal. So coming to next week,
Tiba-tiba admin yang boleh beritahu dalam grup, beritahu kat Miss. Takut dia tak perasan.
sorry, 1 second. Just a bit lag. One second. Okay, nampak dah ke? Ke tak nampak lagi? Nampak dah. Okay. So, alright. So it's very important to know that your nucleus having your proton because of the positive charge and your electron holding the negative charge. Obviously, force of attraction. What is important in the nucleus and your electron is the force of attraction between your proton and your electron. You have one thing called attraction. So it's very important for this.
Madam tak share screen.
Saya dah share dah tapi dia tak keluar. What's wrong? Ataupun kamu tengok saya je lah. Cakap, tak ada lah. One second. Saya dah share dah. I'll leave the call and I'll join back in 1 minute. 1 second. I'm so sorry guys. Just give me 1 moment. Still tak nampak ke?
Tak nampak ni.
Just share dah. Link kedua nampak je. Sorry guys, just 1 second. We'll solve this, you know, and we'll solve it.
Dah
Kenapa
nampak
dia
ni.
tak keluar? Apa dia?
Dah
Dah
keluar.
nampak dah, Miss.
Dah nampak dah pula. It's just being very slow. Sebab kat screen saya memang dia dah tunjuk I'm sharing screen. So sekarang nampak dah?
Nampak ni.
Nampak. Okay. Okay, sebab kalau tak nampak apa-apa, bagi tahulah. Sebab saya nampak je. Please let me know. Okay, please let me know. Semua nampak? Happy?
Nampak,
Good.
Miss.
So we continue. So we are going to talk about, we go back to this Bohr atomic model. So yang penting sekarang dua benda, proton, elektron duduk mana. Yang kedua yang penting adalah, I want to introduce a new term over here, adalah petala kamu. Alright, over here petala kamu, this shell, okay. Dalam bahasa Melayu kamu panggil petala. Kat sekolah dulu, whoever that learn bahasa Melayu dia belajar benda ni panggil petala. Over here, kita guna English. So, I have a simple word for you, energy level. Kamu akan selalu dengar saya guna energy level ataupun shell. So, kamu kena tahu yang ni. Sebab throughout the video, throughout the lecture, I will be using a lot of this. Or, lagi senang bila Miss Wong guna N adalah apa? N tu adalah simbol untuk energy level, N tu adalah simbol untuk shell. So, the one, we will always start with the one closer to the nucleus. This is your nucleus. So, the one that closest to the nucleus will be N equals to 1. Petala pertama. Lepas tu, yang kedua, lepas yang pertama, yang kedua, duduk jauh sikit, N sama dengan 2. Yang tu adalah petala kedua. And then, N sama dengan 3. Yang tu adalah petala ketiga. The first energy level, second energy level, and third energy level. Okay? So, what made up this Bohr atomic model? Kenapa wujudnya Bohr atomic model? Because of Bohr postulate. Before we go into the four postulate, what is actually Bohr postulate? What is the difference between the keyword postulate and also the keyword of theory? Apa beza postulate dengan theory? Theory is something fixed. Proven, betul, fixed, tak ada argument, tak ada weaknesses. Tapi postulate is more on a belief or more on not a theory, more on the theory or a belief that is correct, is true, is proven, but it's not 100% supported by others. Dia ada kelemahan dia kat situ. Walaupun Bohr postulate having weaknesses over here, but it's still the most correct postulate or the most correct atomic model postulate that we have on Earth until today. So whether dia postulate ke, dia theory ke, is still the most correct thing today. Okay? That's why we are still using it walaupun dia bukan theory. 4 postulate that made up the model. And we will go through the postulate one by one. The first postulate over here, electron move in a circular orbit around the nucleus. That is my nucleus, as everybody know. And we know that this is our n equals to 1. We talk about that. This is our n equals to 2. And that is our n equals to 3. And what happened over here, guys, is your electron will be actually in this shell. Okay, your electron will be very specific on the shell. All right. So you have your shell over here. I think I used the wrong pen. Let's go for this one. So you have your electron over here. You have your electron over here. You have your electron in the shell like that. So when you have your electron in the shell, electron is not something that will be static. Electron takkan duduk diam weh. Electron adalah something yang akan forever bergerak tak berhenti. Dan macam mana dia bergerak? It will move in a circular orbit around the nucleus. Bermakna it will be moving like this. Your electron akan pusing just in the orbit. Alright? The orbit adalah petala kamu. So dia akan pusinglah kat petala kamu. Alright? Dia akan pusing kat petala kamu. Dan yang paling penting, daripada jarak yang sama from the nucleus. Kalau kita duduk daripada n sama dengan 1, so the distance from the nucleus will be fixed. That's why bila dia fix, dia akan pusing jadi satu bulatan. Okay? Kalau distance dia adalah jauh sikit, so dia akan pusing jadi bulatan from the nucleus. The distance must be fixed. Alright? That's why only it can circular around the orbit. Circular the orbit around the nucleus. Why the distance will be the same? Kenapa jarak dia sama? Why the electron from the nucleus will be the same? Simple. The charge. So, that is my nucleus having positive charge because of proton. And then I have electron over here that holding negative charge. And kita tahu bila ada electron dengan proton, sayang, kita ada daya tarikan. And kenapa daya tarikan dia sama? Easy. Because the energy for the electron in that energy level is quantized. Kalau elektron saya sekarang duduk pada n sama dengan 1, elektron ini akan ada tenaga yang fix. The energy of this electron is fixed. If I have electron at n equals to 1, 2, 3. So if I have electron at n equals to 3, this electron will have a fixed amount of energy. Dan kalau dia ada tenaga yang dah, orang kata dah takkan berubah, tenaga dia dah fix. So dia ada satu tenaga yang duduk jarak daripada nukleus sama. Sebab daya tarikan. The force of attraction from the nucleus positive charge and the electron negative charge will be fixed because the electron in that particular energy level will have a fixed amount. So semua elektron, tadi kita kata n sama dengan 1 pegang 2 elektron. That is your n equals to 1. Dia pegang 2 elektron. Dua-dua elektron ini sayang, both of the electron will have the same amount of energy. Sebab they are sitting from the same distance from the nucleus. If I have the electron in n equals to 3, elektron ada lagi. Elektron duduk kat n sama dengan 3. Petala ketiga kamu. Semua electron in here, all the electron in here will have the same amount of energy. Okay? And we have formula to calculate that. The energy for this will be negative RH 1 over n square. Okay? Dan kenapa negatif sayang? Sebab elektron bercharge negatif, so daya tarikan dia kat situ. The negative is only to prove the force of attraction. The n, obviously, energy level. Okay, so this is the formula to calculate the energy of this electron in the specific value, in the specific energy level. And since we agree right now, every electron in this specific energy level, all right? So every electron in this specific energy level having a own electron energy. So kalau elektron saya kekal dan duduk pada energy level yang sama. If my electron right now not going anywhere, just circular around the orbit in the same energy level, there will be no energy changes. There will be no energy changes, there will be no energy absorbed or released if the electron remain in the same energy level. Then when I say remain in the same energy level, guys, I have n equals to 3 just now. Remember, we talk about n equals to 3. So we agree on all the electron in the n equals to 3 also having the same amount of energy. And look at the word ground state. One thing that I want to teach you or remind you over here, ground state n is not necessarily equals to 1. Boleh jadi 1, tapi tak semestinya 1. Your ground state means n can be 1, n can be 2, n can be 3, n can be 4. Depends on what? Depends on the energy of the electron. Okay? Every electron having a fixed energy. So kalau energy electron tu sekarang duduk pada n sama dengan 3. So ground state dia adalah n sama dengan 3. Kalau electron teacher sekarang duduk pada n sama dengan 5, saya asal-asal my original is already at n equals to 5. That is my ground state. And as long as my electron at n equals to 5 remain at n equals to 5, duduk bergerak hanya pada petala kelima, duduk bergerak hanya pada sini, there will be no energy changes. The energy will remain the same sebab jarak sama. The distance from the electron and the nucleus remain the same. So energy will remain the same. Okay? If every energy level, setiap petala ada tenaga dia sendiri. Okay? Dan kalau elektron saya berubah petala, alright? Kalau elektron teacher berubah petala, I'm moving up or I'm moving down, then there will be changes. If my electron at n equals to 1, this electron, original n equals to 1, I move up all the way to n equals to 5. First question to you. Selain budak kelas saya. Semua saya nampak nama budak kelas saya. Kesian dia, Pak. I want Amisha Nabila.
Yes, Miss.
If I'm moving from n equals to 1 to n equals to 5, energy is being emitted or energy is being absorbed?
Absorb.
Energy is, sorry?
Absorb.
Absorb. Energy will be absorbed or bahasa senang sayang, needed. Okay? Energy will be needed. Wait, guna konsep senang, naik tangga. You know, I always tell my student, kalau kat makmal kimia tu, kamu kena naik sampai tingkat 4. So, assume your energy level over here is like going up the stairs in the building. So that is your n equals to 1, that is your n equals to 2, that is your n equals to 3, n equals to 4, and then you have your n equals to 5, going up building. And tengah naik tangga. So kalau saya ada elektron daripada n sama dengan 1 nak naik tangga sampai n sama dengan 5. Bila kamu naik tangga, are you using energy or are you releasing energy? You definitely using energy. Weh, boleh cungak weh naik 3, 4 tu. Betul tak? Siapa yang masuk, siapa yang ada kat college lain. Alright? Siapa yang pernah naik tingkat 4, pernah naik tingkat 5, naik tangga tu kamu tahu cungak lah. Okay? So when you cungak means you're using energy. So when you're moving from a lower energy level to a higher energy level, that means energy is needed. I have another keyword over here. Lower energy level and also higher energy level. So over here, your lower energy level is 1, your higher energy level is 5. Alright, if you're moving from N1 to N5, that is your lower, that is your higher. And energy will be absorbed. Okay, energy absorbed over here means the energy will change. There will be energy changes. Perubahan tenaga wujud. Sebab kita setuju tadi, setiap elektron pada setiap petala akan pegang suatu energi, satu energi. So kalau dia bergerak daripada tenaga yang berbeza, then akan ada perubahan lah. Make sense? Alright? And when I say it's moving up, it's not necessarily moving all the way from 1 to 5. We can move as little as, I can move only from 2, I have energy at 2, n equals to 2, move only going up to 3. Daripada 2, hanya naik 3, masih bergerak naik atas, betul? 2 naik 3. So for this transition, this is from n equals to 2 to n equals to 3. My pen today, saya dah ubah sensitivity dia sebab last week tak sensitif, sekarang dah terlebih sensitif. She's betul. Apa yang dia nak saya pun tak tahu. I'm sorry guys, just comment banyak-banyak. A technical problem, I hate this man. So you have your n equals to 2 to n equals to 3 is still talking about lower energy level, higher energy level. Apa-apa yang lebih rendah, that is lower. Apa-apa yang lebih tinggi, that is higher. Dan yang paling penting, naik tangga berapa tingkat pun, you are still using energy. So over here is still energy needed. I told you, man. I told you. When I test it, it was perfectly fine. Sabar, Miss Wong. Energy needed. It wasn't sensitive enough last week, so I changed it. And you're trying to like what? I need to, saya kena, good night kiss every night kat pen tu. Betul tak?
Dia nak minta Miss beli baru tu.
Ada siapa nak bagi hadiah? My birthday is coming, ladies and gentlemen. Thank you. Alright, thank you in advance. Thank you so much, guys. Appreciate it. Alright, semua benda nak beli baru. Nasib baik kamu tak beli baru, Miss Wong. Yeah, what I'm trying to show you over here is tak kisah dia bergerak naik banyak atau bergerak naik sikit. Janji dia bergerak naik, kita akan ada perbezaan tenaga, dan janji dia bergerak naik, dia sentiasa adalah energy needed. And whenever is energy needed, keyword guys, delta E mesti adalah positive. A bit of mathematics over here, ladies and gentlemen. A bit of mathematics, just a bit. Bila positif, wajib tunjuk dalam jawapan akhir. Because the positive sign over here is not showing that it's a positive value. The positive sign over here is represent energy is being absorbed. So especially positive. Negatif saya tak risau sebab bila negatif kamu tekan calculator, dia keluar kat calculator. Tapi bila positif, dia tak ada kat calculator. Tapi kalau jawapan akhir kamu positif tanpa positive value, sign, saya pangkah. So the positive sign over there is a must. Okay? Happy. That is when your electron is moving up. So what happened when electron moving down? Vice versa only. Exactly the same tetapi hanya terbalik. Kalau teacher sekarang ada elektron dari atas, N sama dengan 4. Okay? I told you, they just hit me. What else do you want? Ada siapa nak beli baru kat saya? To make your lecture better? It's for you guys. Alright. Energy level, N equals to 4, ada elektron dan dia jatuh. So it can drop all the way to N equals to 1. So dia jatuh kepada N sama dengan 1. Bila dia jatuh kepada N sama dengan 1 kat sini, elektron drop. And your higher energy level and lower energy level masih konsep yang sama. That is still your higher energy level. That is still your lower energy level. God's sake. Sorry guys. What do you want? Okay. Kena sayang. Okay. I'm not kissing you, the board and the pen. Alright? Yang cakap dok Miss Wong dok sexually abuse. I'm not abusing anyone. The board is abusing me. The electron right now is at higher energy level, drop to a lower energy level. Vice versa, terbalik sahaja. Kalau tadi tenaga digunakan untuk naik tangga. Lepas tu kamu dah naik sampai tingkat 4, tak buat kerja Miss Wong. Miss Wong tolak balik daripada tingkat 4 tu, goleklah kamu turun ke tingkat 1. Alright, Himan duk gelak tu. So when you are going down the stair, even without stepping, sebab Miss Wong yang tolak kamu turun. So no energy will be used, but energy will be released. Why energy will be released? Because you'll be screaming. Alright, that is your energy release. Sebab saya yang tolak kamu. So bila electron jatuh, energy will be released, and vice versa of just now, your delta E will be negative. And similar as what I said just now, the positive and negative is not mathematics. Kita bukan nak tunjuk value tu positif atau negatif, tak. Kita nak tunjuk sekarang adalah the energy is being absorbed or released. Therefore, negative symbol, positive symbol is a must. Okay? And this four postulate, okay, this four postulate is the reason why we have the atomic model that we are drawing until today. This is the reason why we able to draw whatever that you are drawing until today. Even though sekarang pun kita akan lukis cara tu. Where you have your nucleus, kamu ada petala pertama, kamu ada petala kedua, kamu ada petala ketiga. That is the reason. Kenapa elektron boleh duduk sini just like that? Kenapa elektron boleh duduk daripada jarak yang sama? Apa jadi bila elektron kekal dan tak bergerak daripada energy level tu? Apa jadi when the electron is moving up or moving down? Okay? That is your Bohr postulate. Duka cita kena hafal. For me, tak payah hafal pun. If you can draw this, if you understand what I said just now, you can write this out back. Okay? Dan saya letak 1, 2, 3, 4 because the story of the flow is like that. So kalau nak senang, hafal ikut macam tu. Okay? That is the easiest one. The story is there to build your atomic model. And after your atomic model, dalam sekolah, masa sekolah, bukan dalam sekolah, we are drawing this. That is your atomic model. Dan kat sekolah, lukis benda ni tak ada masalah. Okay, we just... Okay. Kat sekolah nak lukis benda ni tak ada masalah. Kenapa lukis benda ni tak ada masalah? Sebab kat sekolah paling banyak kamu lukis 2 petala, 3 petala. Max. Kat sekolah kamu akan lukis paling banyak 3 petala. 3 circle je, tak ada masalah. Lukis lah. 3 bulat je, benda yang paling boleh buat masa exam hari tu. But what happened over here is, I have more than 3. We might come across n equals to 4, n equals to 5, n equals to 7, 8, 9, depends on the question. Weh, gila ha nak lukis bulat sampai 9 bulatan. Bazir masa. So we introduce something simpler that we call energy level diagram. And this energy level diagram is exactly the same thing as the atomic model. Cuma apa beza dia adalah, okay, apa beza dia adalah, we actually cut through this. You have your energy level diagram. What happened is, I cut this into separuh. For God's sake, man. I rather it's not sensitive now. I need to change it back.
Sabar, Miss. Jangan marah-marah.
Saya tak marah kat kamu, sayang. Saya marah kat saya sebab saya pergi ubah sensitivity dia and yeah, trying to show me how sensitive it can be. Thank you. Tapi masa saya cuba kat setting tu okay tau. It's like perfectly fine. Kamu pun tak suka kat saya. Teruk. So, what happened to the energy level? Datang dari mana? Senang je. Saya nak letak nucleus saya. Bila saya letak nucleus saya, then you will be able to see. Nucleus sebenarnya duduk kat sini. Tu nucleus kamu. So, bila kita potong, alright, bila kita potong, nucleus duduk sini kan? Alright, bila kita potong, so that is your N1, N2, N3, N4, N5. See that? That is your N1, N2, N3, N4, N5 going up all the way. Okay? Cuma satu je. Sebab yang ni yang kita akan banyak lukis. This will be the one that you will be drawing in matrix. We won't be using this anymore. Satu je. Just one tiny thing. Look at the way that I draw, the space gets smaller. Siapa yang tengok video, dia akan perasan. Sebab saya insist benda ni. The space must get smaller. And ladies and gentlemen, bukan saya saja. The space actually gets smaller from one energy level to another energy level, and this is a must to draw like this. Tak perlu ukur dengan pembaris, tak perlu bagi tahu, oh teacher dia kurang 0.1 milimeter. Tak. Tapi mata kasar, when I look at it, I need to look at the space getting smaller. Must. Kalau space tak sama, kalau space tak getting smaller, kita potong markah dah, saya tak tanda dah benda tu. By only drawing this guy, alright, where the energy level getting smaller, guys, 1 markah. Tak jawab soalan lagi. And kimia susah. Sepak kepala otak hang. Senang. Okay, syarat 1. Mesti kena getting smaller. From n equals to 1, n equals to 2, n equals to 3, and so on, the gap between the energy level must get smaller. Alright? Easy. Senang je nak lukis. And last but not least, whenever you draw anything, ladies and gentlemen, label is a must. Jangan lukis tanpa apa-apa label. Okay? Next question. Kita panggil, saya ada banyak Amah. Muhammad Amah? Saya ada banyak Amah. Amah mana nak buka mic? Oh, tiba-tiba semua Amah tunggu Amah lain nak buka mic.
Ya, madam.
Soalan teacher. Kalau energy level, wajib, boleh tak teacher nak mula kat n sama dengan 2?
Boleh ikut dia punya ground state kan?
Oh, ikut dia punya ground state. So, jawapan Amar adalah boleh mula lukis daripada n sama dengan 2.
Sekejap, maybe. I think no. N1.
Tak ada thing. Yes or no je. Hidup saya tak ada thing. Hana, you're in my class. Hi, Hana.
Hi, Miss.
Sihat? Yeah, Amar, everybody waiting and everybody dah risau on behalf of you. Diorang duk kata, Habil Amar, you will be dead.
Must be one.
Must be one. Okay. Bina bangunan, simple je teori teacher. When you're building a building, boleh tak kamu ada tingkat 2 sebelum ada tingkat 1?
No.
You go into a shopping mall, guys. You love shopping mall, don't you? How long you never go into shopping mall? I think 2 years for me. So when you go into shopping mall, make sure you know where is the first floor before the second. Because you won't be able to reach the second floor without the first. And like I told you, the first thing that I show you guys, where is the nucleus? And the moment we have nucleus, you must have n equals to 1. Okay? Saya tak nak nampak budak saya jawab energy level diagram mula n sama dengan 2, n sama dengan 3. Saya tak kisah sekarang soalan tu guna atau tak guna. I don't care whether the question using n1 or n2. What I care is my drawing, my building must start from n equals to 1. Is that clear? Okay? Rindu shopping mall kan? And you know the best thing when you're working from home? I think I saved the world. Saya tak tahu berapa lama kereta saya tak payah top up petrol. Semua benda saya beli online, semua benda hantar online. So, it's kind of like great. Okay. Jimat duit. Bagus pak. Alright. So, that is your Bohr postulate over there. And that is your energy level. Nothing big deal. So, I hope you can understand that and memorize it. And if you actually understand it, you don't really need to like memorize. Bagi faham je. Next thing that we want to talk about is line spectrum. Satu proses yang di mana kamu dapat line spectrum. Before we go into the process, blah blah blah, go straight to the line spectrum first. Yang senang dulu. Alright? Tadi dah tengok banyak perkataan, tak nak tengok wording dah. Tengok benda lain pula. Okay. So, line spectrum is like this. I have 2 set of line spectrum. Okay, I have the first set, yang atas. Forgive my drawing, bad drawing. Lepas tu saya ada line spectrum yang kedua. Di bawah. Okay. 2 set of line spectrum. Line spectrum A, line spectrum B. And Hana, sebab saya dah nampak muka kamu kan, and I miss you. So Hana, untuk line spectrum A, okay, kita baca dari kiri atau kanan?
Daripada kiri.
We will be reading from the left, okay, all the way to the right. Bila Hana kata kita baca dari kiri ke kanan, bermakna this is the first line in the line spectrum. Okay, yang lain duk mengangguk. Good. So, my question next. Hana dah jawab soalan senang. Next question. Okay, saya ada Amar 4 orang weh. Amar seorang lagi? Amar orang lain? Tak nak buka mic ke? Saya kena panggil sampai nama bapak ke weh? Amar seorang lagi? Kesian bapak hang bagi nama Amar, lepas tu hang tak nak mengaku. Teruk panggil. Alright. Yeah, Amma. I'm still waiting.
Yeah, Miss.
Okay. Alright, Amma. Kenapa Hana kata baca dari kiri? Tak prepare. Muhammad Syahidan?
Yes, Miss.
Kenapa baca dari kiri?
Dia punya luas tu semakin kecil, Miss.
Thank you. We will be actually identified by only looking at one simple thing, the gap. The gap yang paling luas is the first line. We will always read from the biggest gap. And what I'm trying to show you over here for this line spectrum, dua-dua benda ni kita panggil line spectrum. Okay? This is what we call line spectrum. Thank you guys. So line spectrum nak baca dari mana? Tak ada fix. Kita boleh baca dari kiri, kita boleh baca dari kanan, depends pada soalan. So kalau soalan keluar line spectrum dan dia tak bagi tahu siapa first line, how do we read? That is the most important thing. Very important in the exam. It's only simply by looking at the gap. The largest the gap over here, that will be your first line. Okay? So line spectrum, benda pertama yang teacher nak tunjuk kat sini adalah how your line spectrum look like. That is how your line spectrum look like. Second thing, how do you read your line spectrum? Jangan soalan bagi line spectrum, lepas tu hang tak boleh nak baca. Apa yang teacher nak tunjuk kat sini is not necessary start reading from the left or the right. Depends on the question. Okay? Make sure you know that. Very important. So how do we get this thing? Alright, how do we get the line spectrum? Easy. Ada 6 start. Saya tak payah baca kot. Saya explain terus lah. Baca tu, saya pergi cakap, alah, Miss Wong buka slide, lepas tu membaca je. Apa kutuk pula kuliah saya kan? Susah lah. Susah nak cikgu lah ni. Semua salah cikgu. So, ayat tu ada kat nota, baca sendiri. You have the sentence, so read it. First thing, we have a gas discharge tube. This is actually your gas discharge tube. Okay? And in this gas discharge tube is connected to power. Okay? It's connected to electric, it's connected to power. And in this gas discharge tube, dia ada satu lubang kecil. Alright? Dia ada satu lubang kecil that I can pump my gas into here. Alright, so I put in the gas into the gas discharge tube. Lepas tu buat apa? Buka switch lah, orang dah bagi tenaga kan? So kita pun buka switch. So this power will then supply energy. Okay? When I say supply energy, guys, means energy absorbed. And energy absorbed by what? In the gas, we have a very simple gas. We use hydrogen. Kenapa saya suka guna hydrogen? Because hydrogen only having 1 electron. Okay? So energy, hydrogen having only 1 electron, so who will be absorbing the gas? Kita selalu kata, oh, energy is being absorbed. Siapa absorb energy tu? The electron. The electron will absorb the energy. And what happened when the electron absorbed the energy? The electron just now could be at n equals to 1. Alright? The energy is at n equals to 1. So when the electron, for God's sake, saya kena tukar balik setting dia. It's okay, so. So you have your n equals to 1, electron. This electron right now absorb the energy. So what happened when energy is absorbed? We talk about it just now. Dia akan bergerak naik atas. So nak bergerak ke mana? Tingkat berapa? Pilih. Nak naik banyak ke nak naik sikit? Kita naik banyak sikit lah. Alright, kita lama tak exercise, kena naik tangga banyak sikit. Naik sampai sini. Alright, N 1, 2, 3, 4. So, naik sampai N sama dengan 4. So, obviously, that point is your delta E positive. Energy absorbed. Betul? So, one thing guys, when we talk about gas, when we talk about atom, when we talk about energy, we are only talking about energy of one thing, the electron. The entire video, the entire lecture is only talking about the electron. We are not going to talk anybody else. So the electron absorb the energy and move up. So I show it over here, it will be exactly the same. Electron at N1, move all the way to energy level 4. Electron duduk sini. Delta E positive is the same. Why I put both on side by side? Because I want to show you the similarity between the atomic model and your energy level. Dan pilih, rasa mana senang nak lukis? Bulatan senang nak lukis ke garis senang nak lukis? Right? So always go for this. And then, most important thing, the electron at this place is what we call excited state. Okay? This is the ground state just now. Kita mula kat sini. Your lower energy level right now is your ground state. So kita absorb energy, we move up to the excited state. Teori dia adalah macam teacher baling pen. When we throw the pen, kita daripada ground state, saya baling something. Duduk kat atas. Atas sekarang adalah excited state. Soalan teacher, will this pen last forever up there? No.
No.
Dia akan jatuh balik. Kalau kita baling pen di muka bumi, dia akan jatuh balik. Kenapa? Sebab gravity. Kat sini, kenapa dia jatuh balik? Because nucleus. Betul? Elektron kamu negative charge, dia bergerak sebab dia dapat tenaga, dia bergerak. Okay, dia bergerak sebab dia ada tenaga, dia duduk kat atas. Tapi duduk kat atas akan last forever. Tak, dia takkan duduk kat sana forever. Dia akan jatuh balik sebab nucleus akan tarik dia balik. Okay, that is the reason why at the excited state is very unstable. Kamu ada perkataan ni. The electron at the excited state is very unstable dan dia akan jatuh balik. Next question. Safi. Muhammad Safi. Duduk relax je kat belakang dapur tu. Sayang, duduk kat excited state tu dia akan jatuh balik. Soalan teacher, dia mesti jatuh balik kepada N sama dengan 1 ke?
Yes.
Safi kata dia mesti kena jatuh balik kepada N sama dengan 1.
No.
Oh, no pula. Apa ni? Macam mana ni? Jatuh balik kepada N1 tak?
Medium.
Wajib tak jatuh balik kepada N1? Is that a must to go down all the way?
No.
No. Boleh jatuh balik ke N sama dengan 1. Tapi tak semestinya jatuh balik kepada N sama dengan 1. It's not necessary. It's not necessary where you are, where you from and you drop back to that. No, it's not necessary. So I have my electron at this excited state right now. It's unstable, so it drop. Saya boleh jatuh hanya balik kepada N sama dengan 3. Sayang, semua elektron ini yang ada kat skrin kamu adalah cerita pasal satu elektron. Elektron yang sama daripada 1 naik ke 4. Daripada 4 is at the excited state, is unstable. The electron drop to N equals to 3 only. So, when you drop to N equals to 3, energy release. Alright? Energy release. When energy release, energy will be released in the form of photon. Photon is actually the term for a packet of light. Photon adalah sebenarnya satu paket of cahaya. Alright, kalau tadi kamu naik tangga, lepas tu saya tak puas hati dengan kerja kamu, saya tolak kamu turun tangga, kamu golek. So, energy release kamu adalah sound energy sebab kamu akan menjerit. Okay? Kat sini, the energy release will be in a form of a packet of light. And that packet of light akan go through a machine. This packet of light akan go through a machine and that machine will read the wavelength. Cahaya kan? Belajar kat fizik kan? Cahaya ada lambda. Ada wavelength panggil apa Bian? Wavelength. Tak tahu. Ada wavelength. So wavelength tu akan dibaca oleh satu mesin dan keluar pada spektrum. That is your first line. Okay? So if I have another transition. So kalau teacher ada another transition over here. I have another electron. Tadi satu electron je. I have another electron that move in our energy level. So katakan tadi 1 ke 4. So sekarang teacher ada 2 ke 4 pula. Dan elektron daripada 2 ke 4 ni jatuh balik kepada 1. Same thing, kat sini delta E again release energy. Alright, so bila delta E release energy kat sini, it's like another person is like doing, it's like, you know, it's like someone else is behind me and it's so scary sometimes because I live alone. Anybody behind? Tak ada siapa kan? Takut weh. Apa tak takut duduk sama-sama? Okay, delta E is equals to negative over here. Again, energy release in the packet of light and that packet of light go into a machine and the machine have a wavelength on the line spectrum. Okay? Alright, I think the pen is better bila dia sensitif macam ni because everybody tak mengantuk. Semua gelak je. Tanya. Okay? And bila setiap satu transition jatuh akan hasilkan satu wavelength. That I use the word jatuh. Sebab bila naik, when the electron going up, the energy is actually being absorbed. Betul? So kita tak akan boleh baca. Kita hanya boleh baca bila elektron tu jatuh. The moment electron fall from a higher energy level to a lower energy level, cahaya keluar. Cahaya tu ada wavelength. Wavelength tu akan jatuh on your line spectrum. So that is how your line spectrum being produced. All the 6 steps right now is what I said just now. Okay? Any problem with that? So my question, perlu really hafal ke? It's not really perlu hafal gila-gila pun weh. It's a story. You have a discharge tube. I put in the gas into the discharge tube. I turn on the power. All right, you provide energy. Then the energy is absorbed by the electron. Keyword. Everything is about the electron. Energy absorbed by the electron. The electron move from the ground state to a higher energy level. So dari bawah naik atas. Kat atas jadi apa? Atas tu is your excited state and is unstable. Just imagine kamu dalam exam lupa baling pen pun kamu ingat baling pen jatuh balik. Kenapa? Because it's unstable. When it's unstable, it drop back to the lower energy level. When it drop, energy release. When energy release is in the form of light. And that light will have a specific wavelength and frequency. Okay? Alright? Senang. Boleh? And again, everything is about one electron and all the energy is about that electron. Okay, the entire story is about electron. Okay, kat sini. Ni soalan untuk kamu ni. Lyman series. And
Madam,
final. Yes?
before this, right, Madam drew the energy level line, right?
Mm-hmm.
So then Madam put like, let's say for example in N1, Madam put electron, then line, then on N4 there'll be another electron. But in the module there's no electron. Must I just write like draw the line or must
You
include?
can draw the line with the electron or you can draw the line without the electron. I think what you mean over here is this. You draw the arrow only, right?
Yeah.
Yep. Right? Can. Boleh. the electron can, without the electron also can. In the module, I'm teaching here just now with the electron because I want to show you everything is moving. The electron is the only thing that move. Okay. Dalam exam, kalau kamu tak nak lukis elektron sekali lagi pun boleh. Oh, satu lagi. Since Suran asked about the arrow. Wait, arrow bila lukis dalam exam, make sure dia sampai. Make sure arrow tu sampai pada energy level yang kamu nak sampai tu. Okay? Sebab selalunya, masalah dia adalah kamu lukis, ada budak yang lukis macam ni. Kita tak bagi markah. Alright? Because we know that electron cannot be sitting here, guys. Electron tak boleh duduk kat tengah-tengah tu. Electron mesti duduk pada energy level. So, bila kamu lukis arrow, make sure arrow tu sampai sentuh kat energy level tersebut. Okay? Benda kecil, tapi memang kita potong markah. Alright? Sebab konsep dia, elektron tak boleh duduk kat tengah-tengah. Every single line over here represent energy level. So, the electron must reach until the energy level. Okay? Boleh? Wait, lepas ni, bermula hari ni, I don't want to say this. Okay? Jangan lukis benda ni dalam exam. Bazir masa tahap gaban. This. Okay? And the gap must be smaller. Alright, thank you, Suran. Thank you for the answer. Question. Answer pula. I am the one giving answer. Alright. Over here, nothing much, nothing big deal. Just dua benda je kamu, tiga benda lah. Tiga benda. Tiga benda je kamu kena hafal. Saya guna yang ni terus. Okay, tiga benda je kamu kena hafal kat sini sayang. The name of the series. Okay, the name of the series. And kamu kena hafal the energy final of it. And then kamu kena hafal region. Okay, so if I'm having everything, look at it, everything drop to 1. N2 jatuh 1, 3 jatuh 1, 4 jatuh 1. Yang penting bukan dari mana, yang penting jatuh ke mana. Alright, if everything drop to n equals to 1, n final over here is n equals to 1, that thing we call Lyman series. And Lyman series akan duduk dalam satu region. Sebab tadi kita bagi tahu setiap kali elektron jatuh ada cahaya, cahaya ada wavelength. Semua wavelength ini akan duduk dalam satu region that we call, anybody?
UV.
UV. Nama penuh UV?
Ultraviolet.
Boleh A je kah?
UVRA.
Itu masalah dia. Alright, UV semua boleh tulis. U dengan V je. Ultraviolet region. Okay? Saya tak boleh tulis sekarang. Because my pen bagi tahu saya tak boleh tulis. It's too sensitive. I cannot even press a little bit more. Okay. So that is your ultraviolet region. Okay. So make sure you know these three things. Tiga benda je. The name of the series, the final energy level, and the region. So when everything drop to n equals to 2, when everything drop to n equals to 2, macam saya cakap, it's not where it from. It's talking about where it goes to. When everything is going to n equals to 2, that is your Balmer series. And Balmer series adalah antara favorite dalam exam because dia adalah visible region. Apa maksud visible region? Semua cahaya yang kamu nampak sekarang on the screen of my slide and everything, that is under visible region. Semua color yang kamu nampak dengan mata kamu is what we call visible region. Alright? And obviously guys, n final sama dengan 2. Okay? And then the next one. Nama untuk the next one? Anybody? Afiq? Afiq duduk dekat gila. Afiq Zafri?
Ya, Miss.
The next one? Nama? Lima je nama. Lain kali anak 6 orang macam mana? Anak ketiga dah lupa nama. Girlfriend berapa orang girlfriend? Come on Afiq. Nama?
Tak tahu,
But
Miss.
your n final is 3. Afiq, next week kuliah orang pertama jawab soalan Afiq Zafri. Okay? Over here, that is
Okay.
your Paschen series. And Paschen series, best thing about these 3 series at the end, semua adalah duduk di bawah IR, infrared. Okay? Semua orang akan duduk di bawah infrared region. Okay? Semua duduk di bawah infrared region, that is your Paschen series. And sama dengan 4, bracket. Cuma kena berhati-hati dengan bracket. The spelling of bracket kat belakang double T. Last but not least, N sama dengan 5. When your N final equals to 5, that is your Pfund series. Okay? Tiga-tiga akan jatuh di bawah infrared region. Infrared region is very large region. Sebab tu kadang-kadang remote kereta A boleh detect remote kereta B. One of the reason. Because the region is very large. Okay? So that is your infrared region for the Paschen series, bracket series, Pfund series. Semua benda ni senang je, tapi the details of it ada kat video YouTube. Make sure kamu tengok. Okay? So, last thing and tak banyak. The limitation of Bohr dengan weaknesses of Bohr kita bincang next week sebab saya tak nak kamu confused. Tak apa, sampai sini dulu hari ni. So, kita terima semua benda yang Bohr proposed to us today from the Bohr postulate making up to your Bohr atomic model. The importance of the atomic model is to explain the formation of line spectrum and the formation of all this series. Look at my series, I'm still using the energy level. Where is this energy level come from? From the Bohr atomic model. Alright? So the Bohr postulate is the reason why we have all this. The main thing that you have this entire topic. Okay? And next week, we will be going a bit more, 5 minutes, 10 minutes about this Bohr atomic model. And then we will be going into 2.2. 2.2, best. I can ask a lot of questions. Sebab jawapan dia nombor je. Simple, easy answer, but very new thing. So be prepared with that. Okay? Question? Dan orang pertama jawab soalan, guys, ingatkan saya, Afiq Zafri. Because you cannot even answer Paschen series just now. You did not prepare for my lecture. Alright, attendance, make sure scan, jangan lupa. I'll see you next week for your 2.2. And I'm so sorry about the pen just now. Forgive me. I'll try to make it better, I promise. So sorry.
Thank you, Miss.
Thank you. Off you go. Have a good day and take very good care of yourself.
Thank you,
Thank you, Miss.
Thank you, Miss.
Thank you.
Thank you, Miss. Thank you, Miss.
Thank you, Miss. Make sure you take good care of yourself. Thank you. Have a good day.
Thank you, Miss.
Thank you.
Thank you, Miss. 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 Thank you, Miss.
Thank you, Davanis.
Thank you, Miss.